Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over lesson 7.6, solving quadratic trigonometric equations. Now, what you guys did in 7.5 was solving linear trigonometric equations. Today we're doing solving quadratic trigonometric equations. So the purpose of this lesson, we're just going to go through a couple questions to get you guys all warmed up. So let's look at example 1. Sine squared x minus 2 sine x minus 3 equals 0. So this is the equation, and what we're doing is we are solving for x, okay? The whole purpose of solving these equations is to solve for x. Now with trigonometric equations, they're going to actually give you an interval, and a lot of people get scared when they see this because they don't know what it means. All it means is we're only solving the solutions, because remember, a sine function goes on and on and on and on and on forever, right? But we only want the solutions between 0 and 2 pi. So only within this section, we want the solutions. So that's why they give us this, this range. Now, sometimes they may give you a different range, so that's just to throw you off. You know, you just got to make sure that the solutions you're finding are within that range, okay? So let's look at the first question. If we look at this sine squared x minus 2 sine x minus 3, we can kind of see it resemble a quadratic equation because we have the squared, the regular term, and then the number. So let's factor this equation. So the first step is we got to factor this. So a lot of the times in these quadratic ones, we're going to be factoring. So if I factor this, I'll get sine x minus 3 and sine x plus 1 equals 0. Now what I'm going to do is from these two factors, I am going to solve for x. So sine x minus 3 equals 0, sine x equals 3. And then what we can see here is when it says sine x equals 3, I know that my sine function, it only exists within the bounds of 1 and negative 1. So sine x equals 3 doesn't even exist. It's completely out of the bounds. So this will give us no solution. Okay, so this is something you want to make sure. If you get something like this where it says sine x equals a number that's outside of the bounds of 1 and negative 1, it's going to be indismissible. It will be no solution. But if you look at the other factor, sine x plus 1 equals 0, sine x equals negative 1, where does sine x equal negative 1? Sine x is equal to negative 1 right here. So if you see this, this right here happens at 3 pi over 2 and negative 1. So here, x would be 3 pi over 2. And this is your only solution. So in this case, we factored it. We tried to get two solutions. We found out that one gave us no solution, but the other one gave us 3 pi over 2. And we make sure, okay, is 3 pi over 2 in between the 0 to 2 pi? Yes, it is. Cool. Good. Now we can go to the next question. And that's all it is, guys. It's very, very simple. Okay, let's try another question. Cosecant squared x minus cosecant x minus 2 equals 0. And let's do this on the same interval from 0 to 2 pi. So first what we're going to do is we're going to factor this to cosecant x minus 2 and cosecant x plus 1. And then we're going to solve for these two individually. So this is going to be cosecant x minus 2 equals 0. So cosecant x equals 2. And remember, cosecant x is the same thing as 1 over sine x. So if cosecant x is 2, then sine x would equal 1 over 2. Okay, and the reason I want to put it into its primary trig ratio is because it's going to help me when it comes to the cast rule. So if you look at this, sine x equals 1 over 2, I'm actually going to put this on my diagram. And from here, sine x equals 1 over 2, I know using the cast rule, this is actually going to exist 2 times. It's going to exist in the A quadrant because sine is positive, and it's also going to exist in the S quadrant because sine is positive. And we know sine is opposite over hypotenuse. So the question we got to ask ourselves is, what is this guy, which is theta 1, and what is this guy, which is theta 2? In fact, it's not, because we're using x, I'm going to use x1, and what is x2? So this is actually going to give us two answers. Now, we know through special triangles that x1 is going to be pi over 6, because we are using the special triangle pi over 6, pi over 3, 1, 2, root 3. So we know that the x1 has to be pi over 6. So how can I find x2? x2, we just do pi minus pi over 6. And then when we subtract fractions, we got to get a common denominator, which leaves us with 5 pi over 6. So as you can tell, just from this factor alone, we were able to get two solutions. But we're not done yet. We got to go to the other factor. So let's go to the other factor. Cosecant x plus 1 equals 0. Cosecant x equals negative 1. So remember, we don't want to keep it as cosecant x. We want to make it as sine x. So sine x is equal to negative 1 over 1. So 1 over negative 1, which is still negative 1. And then now that I have sine x equals negative 1, I can just use my knowledge because I memorized the sine graph. Right? We always want to make sure we have our sine graph memorized. And where is the negative 1? It's at 3 pi over 2. So we'll call this x3 is 3 pi over 2. So in this particular problem, we actually had three solutions. So you see how sometimes you're going to be using the sine graph, right, to find your solution. And sometimes if you get a fraction, you're going to be using the cast rule to find your solution. Now usually when you're using the cast rule, you're going to get two solutions. But when you're using the sine graph, you're probably going to get one solution. Okay, let's try another one. So let's look at example 3. We have 2 secant squared x minus secant x minus 1 equals 0. And we're going on the same interval from 0 to 2 pi. So let's first factor this out. So you're going to get secant x minus 1, and you're going to get 2 secant x plus 1. Okay, let's make this secant x minus 1 equals 0, secant x equals 1. So if secant x equals 1, we got to find out what cos x equals, because cos is the primary trig ratio of secant x. So we just do 1 divided by 1, which is also 1. Now this is nice because cos x equals 1. We know how the cos x graphs looks like. It looks like this. So where does cos x equal 1? It actually happens 2 times. So the first x value is going to happen at 0, and the next x value is going to happen at 2 pi. So from just this side, we got 2 solutions. Now let's do the other side. 2 secant x plus 1 equals 0. 2 secant x equals negative 1. Okay. And then we're going to go secant x equals negative 1 over 2. Now we got to do cos x because we want the primary trig ratio, which is 2 over negative 1, which is negative 2. Now obviously we know cos x only exists between 1 and negative 1. Right? This is what we know. It only exists between 1 and negative 1. So negative 2 would actually be somewhere here, which does not exist. So here we have no solution. So we only got 2 answers. We only have 2 answers. So let's actually do one more question. Let's do something with the tan. You know, we haven't touched the tan yet. So let's look at this one. Example 4. You got tan squared x minus tan x minus 6 equals 0. And we're going to go again from 0 to 2 pi. So let's first factor this out. We got tan x minus 3 and tan x plus 2 equals 0. So here we got tan x minus 3 equals 0, tan x equals 3. Okay. Now, tan x equals 3 is different. It's not like sine and cos, because sine and cos, we know they're only going to be bound between 1 and negative 1. Tan x, remember the graph, it kind of looks like this, right? So it's a bit of a different kind of function here. Now, this tan x is actually 3 over 1, right? That's how I want you to think of it, 3 over 1. And the reason I want you to think of it like that is because we can actually put this in our cast rule. So we know tan x is positive, so it's going to be in this quadrant, the A quadrant, because it's positive. And it's also going to be in this quadrant. And we know that it's opposite over adjacent. Opposite over adjacent. So the question then becomes, okay, this right here is going to be our x1, and this right here is going to be our x2, because we go from principal arm to terminal arm. So how do we find x1? I'm going to find x1 by doing the tan inverse of 3 over 1. And remember, when you do this, make sure your calculator is in radians. So what you'll end up getting by doing this is you'll get 1.25 rad. So notice this is not a special triangle, okay? So sometimes you might get a question where it's not a special triangle and you guys got to improvise from here, right? So you guys got to put it in rad. Now that I got that x1 as rad, I can find x2, which is just going to be pi plus the 1.25. So x2 is going to be pi plus the 1.25, which gives me 4.39 rad. So there you have it. We got our two x values from this. Remember, this is just from the left side. Let's do the other side. Tan x plus 2 equals 0. Tan x equals negative 2. So remember, we're going to rewrite this as tan x equals negative 2 over 1. Now for this one, we got another cast rule going on. But this time, we know tan is negative. So if tan's negative, it's going to appear in this quadrant, and it's going to appear in this quadrant. So tan is negative 2 over 1, negative 2, sorry, this is going to be positive 2 over negative 1, and then negative 2 over positive 1. Okay, so first, we got to actually find out what that x value is. So if I take the tan inverse of negative 2, I'll find my x1. Well, I'll find my x, which is my reference angle. So I'll call this xr for the reference angle. And the reference angle I'm going to get is going to be 5.18 rad. Sorry, not 5.18 rad. That's wrong. Let me just double check this in my calculator. So the inverse of tan of negative 2, we get negative 1.1. So mind you, when we do this, a good practice, guys, for these kinds of questions is to use the absolute value as if we were pretending the graph was actually located here. Okay, and I want you to get into this practice because it just helps us get the reference angle a lot easier. So instead of doing this, I'm going to actually do the tan inverse of positive 2, okay? And I'll show you why. It'll make a lot more sense as I go through it. So when I do the tan inverse of positive 2, you end up with 1.11 rad. So that means if this function is, if this angle were to exist in the first quadrant, it would actually be 1.1 rad. So now obviously we don't want the red triangle. We want the other two triangles. So I actually want this to be my x1 and this to be my x2. So from this 1.1 rad, I can actually find x1 because I know it's going to be pi minus 1.1 rad, 1.11 rad. So x1 is actually going to be 2.03 rad. That's going to be my first guy. And then the second guy is going to be 2 pi minus 1.1 rad. So x2 is going to be 5.18 rad. So as you can tell from this particular question, we have 4 solutions. 2 that came from the cast rule from the first tan side, and 2 that came from the cast rule from the other tan factor. So hopefully this makes sense, guys. You know, it's very, very simple. We're just solving for x, factoring, and then getting the 2 things. Now, from these 2 answers, sometimes you're going to use the cast rule, sometimes you're going to use the actual sine graph or cosine graph. Your job is to find these factors and find out that sometimes they're indismissible. Sometimes they don't exist, right? Look at this. You will get no solution sometimes. So hopefully this video helped you guys a lot. If you found this video helpful, you know, feel free to drop a like, subscribe to the channel. We post videos like this all the time, Monday through Friday. And if you're somebody who needs tutoring, feel free to click the link in our description and our team would love to get in touch with you guys. Without further ado, I'll see you guys in the next video.